Why are humans locked inside the solar system by just two cosmic walls? Even more strangely, when Voyager 1 looked back at Earth from 6.4 billion kilometers away, the photos showed almost complete darkness, while from Earth, we see countless stars. Is this all just an illusion? Or is something preventing us from discovering the secrets of the universe? As early as 1950, Dutch astronomer Jan Oort discovered strange patterns while studying comet orbits and periods. He suggested that long-period comets may originate from a distant region outside the solar system, later named the Oort cloud. Although its existence can be indirectly inferred from comet trajectories and aphelion distributions, the Oort cloud is too far to be directly observed. To uncover the truth, nations have invested heavily in unmanned probes, seeking the secrets behind the twinkling stars. Yet, on the cosmic scale, human probes are almost powerless. Even the solar system, just 2 light-years across, cannot be easily escaped. Still, there were unexpected discoveries. In January 2003, Pioneer 10, stable for nearly 30 years, encountered strong electromagnetic radiation and sent back strange signals before losing contact. Voyager 1 and 2 experienced similar unknown interferences. Analysis revealed a terrifying fact. Our solar system is enveloped by a mysterious force, which seems to protect Earth, while simultaneously restricting human activity. This force resides in the heliopause, or the boundary of the solar sphere, composed of the midwave layer and a nearly spherical diffuse structure. It accumulates vast solar winds, forming a scorching hydrogen wall about 2 billion kilometers thick, with temperatures around 50,000 degrees Celsius. Voyager survived this region because the particle density is low, and without air molecules, large-scale conduction cannot occur. In other words, the heliopause protects the solar system from interstellar radiation but also acts as a firewall, limiting human activity. Scientists predict that if the Oort cloud exists beyond the heliopause, its width may exceed 2 light-years, meaning Voyager 1 would need 30,000 years to traverse it. Simulated models show the Oort cloud as a massive spherical structure wrapping the solar system like cosmic shackles, confining human activity. While the existence of the Oort cloud remains unconfirmed, if the Earth prison paradox is true, the dazzling Milky Way we see might be nothing but a virtual projection cast by this giant sphere. Perhaps physics itself is an illusion, and all astronomical observations and scientific evidence are deliberately designed under cosmic rules. So, if the Oort cloud didn't exist, what would the universe we observe really look like? If you could travel at 1 light-year per second, where would you end up? The speed of light is the fastest known speed in the universe, about 300,000 kilometers per second, enough to circle the Earth 7 times in 1 second. Yet in the vast cosmos, light itself seems slow. Escaping the solar system would take at least a year. A light-year is the distance light travels in a vacuum over 1 year, about 90 trillion kilometers. Now, imagine your spaceship moving at 1 light-year per second. In just 1 second, you could leave the solar system. After 4 seconds, you arrive at the nearest star to Earth, Proxima Centauri, a 3-star system, and the hometown of the Trisolar ants. After 8 seconds, you reach the brightest star in the night sky, Sirius. After 10 minutes, you arrive at the most habitable exoplanet known, Kepler 22b. At our current technology, it would take over 10 million years to get there. Continuing your journey. After 2 hours, you reach the breathtaking Pillars of Creation, ranked among the top 10 photos taken by the Hubble telescope. After 5 hours, you encounter the largest known star, Stephenson 218. Its radius is 2,158 times that of the Sun, capable of holding 10 billion suns, or 130 quadrillion Earths. After 1 day, you leave the Milky Way behind, witnessing the galaxy in all its glory, spiraling arms dotted with stars, an awe-inspiring sight. After 29 days, you reach the closest galaxy to the Milky Way, Andromeda. Larger than our galaxy, it is expected to collide with the Milky Way in 4 billion years. After 115 days, you reach the outskirts of the local group, composed of the Milky Way, Andromeda, and around 50 other galaxies. After 3 years, you realize the local group is just part of a much larger structure, the Virgo supercluster. After 16 years, You finally exit the feather-shaped Laniakea supercluster, with the Milky Way merely a tiny dot on a cosmic feather. Further ahead, after more than 100 years, you encounter the largest known black hole, TON 618, with a mass of 6.6 billion suns, a truly terrifying cosmic entity. After over 1,000 years, you reach the edge of the observable universe, about 46.5 billion light-years from Earth. Yet this is not the true edge, merely the limit of human observation. Beyond it, the universe may continue endlessly. Even at this mind-boggling speed, we cannot touch the actual edge of the universe. It is humbling to realize just how insignificant humanity is in the grand cosmic scale. In the vast depths of the universe, there exist 5 terrifying cosmic objects beyond human imagination. Each one defies our understanding of physics, life, and cosmic order. The last one is so powerful that even black holes seem insignificant in comparison. 5th place, supernova. When a massive star reaches the end of its life, its nuclear fuel is exhausted. The outer layers collapse under gravity, compressing into the core. Then, under immense gravitational energy, the core violently rebounds, ejecting all matter at near-light speed and sending shockwaves into the surrounding interstellar space. This is the terrifying supernova explosion. The energy released is equivalent to hundreds of years of radiation from the entire Milky Way, capable of instantly wiping out all life within 50 light-years. It also unleashes the universe's ultimate weapon, gamma-ray bursts. A single photon can be hundreds of thousands of times more energetic than a solar photon, obliterating anything in its path. If a nearby massive star were to explode, we might see 2 suns in the sky, but this would also mean imminent apocalypse. 4th place, neutron star. Neutron stars are the densest objects in the universe after black holes. They form when a star about 29 times the mass of the Sun collapses after a supernova. Enormous pressure compresses electrons into atomic nuclei, forming neutrons that coalesce into a neutron star. Though tiny, about 0.004% the size of Earth, a neutron star's gravity is extreme. A single cubic centimeter weighs around 1 billion tons. Coupled with intense magnetic fields and high-energy particle winds, it can easily destroy stars. If you were captured by one, its magnetic forces would tear you into atoms, stretching your molecules into thin strands before merging them with the neutron star itself. 3rd place, black hole. Black holes are the ultimate devourers. Nothing, not even light, can escape. When a supermassive star collapses, its core's gravity captures the supernova's explosion and warps space itself, forming an expanding bubble. When the bubble's growth balances with space contraction, a black hole forms. Nearby, space-time is twisted to the extreme. Matter and light spiral into the center, and time itself seems to point toward the core. While humanity has captured the first image of a black hole, its formation mechanism remains a mystery. Perhaps inside, an entirely enclosed world exists beyond our comprehension. 2nd place, quasar. Quasars are massive, star-like objects, detectable mainly via radio waves. They are the brightest and most active objects in the universe. Even the nearest quasar, 10 billion light-years away, shines 430 trillion times brighter than the Sun, emitting energy a trillion times that of our star, with diameters exceeding 1 light-year. Scientists suspect the core may be a black hole consuming surrounding matter at incredible speed, emitting dazzling light. Others hypothesize it could be a white hole, violently ejecting material outward, producing enormous energy and powerful light beams. Either way, quasars are cosmic beacons of energy and power unlike anything else. 1st place, giant shadow ape. The most terrifying cosmic entity, the giant shadow ape, pulls the Milky Way at 600 kilometers per second, dragging hundreds of galaxy clusters, including the Virgo supercluster, toward itself. Located 650 million light-years away in the Laniakea supercluster, with a width of 400 million light-years and mass 10,000 times that of the Milky Way, it exerts extreme gravitational force. Even black holes appear minuscule. Under its pull, the Earth, the solar system, and the entire Milky Way move inexorably toward it. While theoretical models suggest it may be formed from multiple massive structures, cosmic dust blocks direct observation, leaving us uncertain whether other unimaginable, mysterious objects exist at its gravitational core. These 5 cosmic horrors, from supernovae to the giant shadow ape, reveal the sheer terror and grandeur of the universe. Standing before them, humanity's fragility and insignificance become painfully clear. If you're fascinated by the mysteries of the universe, don't forget to like and subscribe. See you in the next video.